The fourth video for this week is for testing mediation. Now if you refer back to, let's see if I can get this figure back. Whoops. Excuse me. If you refer back to this figure, this is the common figure or the set of figures that we see for mediation. And you'll notice that we have one dependent variable, y, but we also have m as a dependent variable for x. So we're accustomed to only having a single dependent variable in multiple regression and correlation. So therefore, what we have to do is we have to test mediation in multiple models when we're using regression. So if I shift back to, excuse me, to R, where what I'm going to do is I'm going to show you step by step how to do that. But first I'm going to create some data. I'm going to create X, M, and Y. And that's what I've done here. And the first thing that I'm going to do is I'm going to test for parameter C. And parameter C is this effect between X and Y omitting M. Now why are we doing that? Barron and Kenny, the original source that most people cite about testing mediation, recommended to test this. The strange thing is we never include C unless we're calculating the difference between C and C prime, which is rare. Most of us, what we do is we test this model up here and we ignore the direct effect. But nevertheless, what I'm going to do is I'm going to test y and x, and what I get is I get a coefficient. Okay, and you can see that x and y have a significant relationship. This is my b and my standard error, my t-value, and it's significant below the 0.05 level. But all that is fine. I think what you need to establish that there is some relationship between x and y. The problem is if it's a fully mediated relationship, that c actually may be non-significant. Nevertheless, excuse me, we carry on. And the first thing I'm going to do is I'm going to test my A parameter. And my A parameter tells me that there is a significant difference between x, a significant relationship between x and m. So what is that telling me? It's telling me that this effect right here is significant. So what we'll do is let's just put an asterisk, if I can actually do that. Yep. Okay. All right. Now, so I put an asterisk there, and let's move back to our results. So we'll need A in a little bit, and then I'm going to test two parameters, B and C prime. Now, why am I testing two parameters in this model and only one parameter in the previous model? Well, it's because Y is a dependent variable, and I have X and M both as predictors. So I'm going to get B and C prime from this third regression model. And that's what I get. This is my B parameter right here, and that tells me that my B parameter is a significant parameter between M and Y. So if I move back here, I'm going to put an asterisk here. I'm going to use my pen. And you notice that this one's non-significant, but this one was. So we have a significant A, a significant B, and a significant C, but C prime is non-significant. Now how do I get that? Right here. X to Y, remember this is my C prime parameter, is non-significant. It's above 0.05. So therefore, I have a significant effect between X and Y, and I have a non-significant effect between X and Y when I include M. Now I manufactured this data, and if you follow the logic, what I've done here, I've created a random normal variable of X, and then M is just X plus a random, so it's X plus noise, and Y is M plus noise. So indirectly, X and Y have a relationship, as I've shown here. I've shown here that X and Y do indeed have a significant relationship. But when I include M in the model, the relationship, the relationship between X and Y goes away. And that's right here. That's my C prime. Now this is, according to Barrett and Kenny, this is where most people would stop. But since Barrett and Kenny, there have been multiple ways in which we can test mediation. And testing mediation, the best way to do it is to, or at least the initial step, is to calculate the Sobel test. So the Sobel test requires us to use the A and B coefficients, that is the unstandardized regression coefficients, the B's, for this A parameter and for this B parameter. Okay, those are the only two that we need. We calculate A and B, and then we also extract the standard error of A and the standard error of B. And the reason for that is, one, we need to test the indirect effect, which is A times B. And so that is this parameter. Remember, these are unstandardized parameters. Not standardized, but unstandardized. They're in the metric of rise over run, or Y over X. Okay? Because this is a bivariate model, this B parameter is very simple. It is just in Y over X. But remember that B is going to be a partial regression coefficient. So what you have is you have a regression coefficient here that's a bivariate times a partial regression coefficient, or a partial correlation coefficient with respect to the metrics of Y and M. But we multiply these two because in order to get the relationship, the indirect relationship between X and Y, we have to multiply these two parameters, this A and B. By multiplying them, we get the numerator in what's called the Sobel test. And the Sobel test is a way in which we can assess whether the parameter between X and M, between X and Y through M is significant as an indirect effect. So the numerator is A times B, that is the A regression parameter times the B regression parameter, divided by a standard error in essence, because it's just like a t-score. And remember, when we calculate t, like right down here, we calculate t by getting a parameter estimate, and then we divide by the standard error. Well, that's what this is. So the numerator is A times B, and the denominator is the square root of A squared, the parameter estimate of A squared, times the standard error of B squared. Okay, I know it's backwards. It looks backwards and it looks wrong, but it is not. So it's the A parameter squared times the standard error of B squared plus B squared times the standard error of A squared. And you take the square root of that entire operation. After you do that, S out is just what I called it. It's the numerator over the denominator. After you calculate that out, we've got a number that's 7.21204. And that is essentially a Z. Now, remember that Z-scores, we know that 1.96 is 95% approximately, right? We've learned that a long time ago. But take a look at this. This is the p-value associated with a Z of 7.2, which is 2.75 times 10 to the minus 13th. So that's a teeny tiny number. And that's the p-value associated with that Z. And in R, there are all sorts of functions that you can run. Here's one where there's a library called multi-level, and what you get is 7.21204, same number that I got before. You can see here with the p-value associated with that Z of that. Okay, so now what I've done is I've run through testing mediation. Testing mediation involves, in the simplest form, testing mediation involves first identifying the parameters of interest, and that is A, B. Now remember that C star, or C, excuse me, and C prime, C and C prime, are both parameters that we estimate in the model, but they're not necessarily used in the Sobel test. But A and B are. So we have to calculate our first regression. Our first primary regression is between X and M, and then our second is with Y as a dependent variable and X and M as predictors. The only things that we extract from this to test the indirect effects are A times B, and we divide by a standard error that we calculate using a very simple formula. When we do that, we get a Sobel test estimate, which is z-score distributed, and that z-score distribution, we can get a p-value associated with that to find out whether we can reject the null that the indirect effect, that is A times B, is significantly different from 0. When we do that, if we do indeed reject the null, what we say is that the probability that the data would be observed given the null hypothesis is less than 0.05. And so therefore we reject that the indirect effect is 0. Now this is a test, not necessarily of mediation, but it's a test where we fail to rule out mediation. By failing to rule out mediation, what we do is we say we consider it as a potential effect in our model. And remember from the previous videos, what I talked about with respect to mediation is that mediation is a causal statement. And so when we fail to reject the potential for that causal relationship, what we're saying is that there is potential that this mediation effect exists. I know that sounds very wishy-washy and not terribly demanding of our data, but that's the extent that we can make firm conclusions from this type of test. The following videos are going to address some of the limitations of the Sobel test, because while it tends to be the standard of the first step of testing, there are some problems with it. So stay tuned for the next few videos in which we'll discuss this in a little bit more detail.